So far, we've seen that we look at two main types of sequences in matric: arithmetic sequences and geometric sequences. And so whenever we are given a sequence, our first strategy needs to be to decide what type of sequence that is. So we start and we look for constant differences. Constant first differences, like what we see in this example, mean that we are dealing with arithmetic sequences. When we look at geometric sequences, we'll start to notice that there aren't constant differences, neither first nor second constant differences. And that's when we start to look for a common ratio. And once we have a common ratio in place, we know that we are dealing with a geometric sequence. We looked at those two different formulae in our previous video, but just a quick recap. If you're dealing with an arithmetic sequence, you use this formula: Tn is equal to A, first term, plus n minus 1 d, constant difference. And if you are dealing with a geometric sequence, then you use this formula: Tn is equal to A, your first term, multiplied by r, that's the common ratio, to the power of n minus 1. Now we're going to move on to the concept of series. So the difference between a sequence and a series is very minor but very important. In a sequence, you are given terms and they are listed, usually with semicolons between. But in a series, what they want us to do is to add the various terms of the sequence. And so whenever you are given these addition signs in between your terms, you know that you're dealing with a series. Your initial approach can remain the same when dealing with a series. You can figure out what you did to get to the next term in each case. And as we've seen earlier, we are adding 9 in each case here to get to the next term in this series. But now we are going to need to use slightly different formulae because we're no longer looking for Tn, we are looking for the sum of this series. Now for an arithmetic series, we've got two options that we could use. Okay, this one will be given to you on your formula sheet, the first one, and it always works. The second one you can memorize. It's not going to be given to you on your formula sheet, but this one only works when you have the last term in the sequence. So let's have a look at each of them. They're both helpful. The second one is just a little bit more compact. So if you are asked for the sum of this series, then what you'll do is they'll normally say to you for a certain amount of terms, so for 10 terms or whatever. Then you could say the sum of 10 terms, and now everywhere you see n, you'll substitute with the number of terms that they've asked you to use. And then the rest of the formula goes like this. So n over 2, and then you multiply by everything in this bracket. So it's now 2 multiplied by a, your first term, and then plus n minus 1 multiplied by d, the common difference. On the other hand, sometimes they will give you a formula and they will actually show you the term it ends with. So you'll see a whole lot of numbers plus ... to show that there are more terms missing, and then they'll give us a last term in this series. Then we can go to this formula here and we simply say n over 2, okay, if we know how many we're dealing with, and then is equal to a, our first term, plus l, our last term. The best way to check our understanding of this work is to tackle some examples. So have a look at this one. Determine the sum of, here's the series, 5 plus 10 plus 15 plus 20 plus plus plus, if there are 50 terms in the series. The best place to start is to start by putting the formula down so that we know what we're dealing with and we know what we're looking for. If we look at the series that they've given us here, 5, 10, 15, 20, the first thing that I normally do, given any sequence or series, is I look for the constant difference. So I say, what did I do to 5 to get to 10? I added 5. What did I do to 10 to get to 15? I added 5. And there it is, nice and easy to see that the value of d is in fact 5. Then we need the value of a to fill in our first term there. So a is also equal to 5. And then finally, to complete this formula, how many terms are we dealing with? That's n, and there are 50 terms. So we are now ready to complete the formula. The sum of 50 terms is equal to 50 over 2, 2 multiplied by our first term a, plus 50 minus 1 multiplied by that constant difference of 5. And you can type all of that into your calculator to get to an answer of 6,375. So what is the sum of the first 50 terms of this series here? 6,375. Okay, let's have a look at the second question. So the original question said, determine the sum of, and then we've got these numbers here, 8, 6, 4, plus, all the way up to minus 12. Okay, so a good place to start, again, is looking at the series we've been given and then figuring out we've got two formula options, because I can see here that we've been given our last term, which is minus 12. So there's a chance that we can use this one here because we do have the last term. But let's have a look. 8 plus 6 plus 4. Remember, what we do is we look for that constant difference. So 8 plus 6 plus 4 plus all the way up to minus 12. Let's identify our differences there. So minus 2, and we assume that's going to continue. All right, so what have we got with regards to this sequence? We know that A is our first term. We know that D is that constant difference of minus 2. And then we need one other thing. We need to know the value of n, because either of these formulas requires an n value. Now that's tricky because I don't know how many terms there were between these two plus signs. And so that's where we're going to have to go back to our knowledge of the arithmetic sequence, because that helps me to figure out term numbers. And I would like to know, what is the term number here? Tn question mark. We don't know what that is. Okay, so let's go back to that formula. Tn is equal to A plus bracket n minus 1 multiplied by D. Now, think carefully to what we've learned before. We want to know how many terms there are. So we're going to substitute our last term in there for Tn. We want to know which term is equal to minus 12. Now we've got the A value. We already wrote that down. We said that was 8 plus n, that's the thing we're working out, minus 1 multiplied by that D there is minus 2. Okay, so now we're ready to go. Minus 12 is equal to 8 plus, not plus, because we're going to actually multiply this minus 2 into the bracket here. It's going to end up being minus 2, n plus 2. And then we can solve this equation. So let's take this 2n across, this minus 2n across. It's going to become positive 2n on this side, and it's going to equal to 8 plus 2 is 10, and then we're going to get another negative 12 is going to become plus, so it's going to be 10 plus 12, so that's going to be 22, and then finally n equals 11. Okay, so how many terms do we have? We've got 11, and that helps us out. So if you come back up here, we've got A is 8, D is minus 2, and n is 11. And now we can really choose either of these formulae, but I'm going to use the second one just so that we can practice it. So Sn is equal to n over 2 bracket A plus L. And we know now that there are 11 terms in this series. So it's 11 over 2 bracket A had a value of 8 plus our last term there was minus 12. And now we can calculate. 11 over 2 multiplied by 8 minus 12 gives us an answer there of minus 22. So the sum of this series is negative 22. Now let's have a look at a geometric series. So again, similar to a geometric sequence, except there are now plus signs in between. Okay, and as usual, we want to start and we look, is there a constant first difference? That's an arithmetic sequence. Is there a constant second difference? That's a quadratic series. If there is a constant ratio or common ratio, that is going to be a geometric series. So we've already seen if we multiply by 4, in each case, we end up at the next term in the series. And here we have the formula for a geometric series. So sum of n terms, remember they tell us how many terms, is equal to A, that's our first term, and then in brackets R, so that's the common ratio there, to the power of n, again the number of terms, minus 1, and then all of that is divided by r, the common ratio, minus 1. Let's try some examples. Given the series 2 plus 4 plus 8 plus 16, determine the sum of the first 10 terms, and then determine the number of terms in the series if the sum is 65,534. Okay, so a good place to start is just to jot down the formula so that we know what we're looking for. So Sm, that's our sum formula, is equal to A, first term, R, common ratio, to the n, number of terms, minus 1 over R minus 1. Okay, so if we look at this series here, what do we do to figure out the common ratio? Remember we said R is equal to term 2 divided by term 1. And we can use any consecutive terms here. You can use term 50 divided by term 49. And if it's a common ratio, you will get the same answer. So term 2 is 4, term 1 is 2, so the common ratio here is 2. So now we've got our R value. A, that's our first term, so A is equal to, there it is, a 2. And then finally, N, the number of terms here, they've told us is 10, so we're going to use an N of 10. Okay, so let's substitute sum of 10 terms is equal to A, that's 2, bracket, R is 2 to the power of N, minus 1, all divided by 2 minus 1. And then we can calculate, and we get an answer there of 2,046. Now they say determine the number of terms if the sum is 65,534. Okay, so again, we've got the formula, Sn equals A, brackets R to the n minus 1, divided by R minus 1. But now, what we know is actually this value here. The sum is going to equate to that 65,534. Okay, so let's sub that in. 65,534 is equal to A, our first term, so 2, bracket R, 2 to the power of n, because we don't know now number of terms in the series, so that's our n value, minus 1, divided by R minus 1. Okay, and now we're going to work out. So 65,534 is equal to, if you look at what's happening here underneath, 2 minus 1 is just 1. So we don't need to write that denominator there of 1. Okay, let's divide both sides by 2. So we end up then with 2 to the n minus 1 is equal to 32,767. Okay, then we're going to move this minus 1 over. It's going to become a plus 1. So we are going to then end up with 32,768 is equal to 2 to the n. And now to solve this, we want to try to get the same bases on each side. So how can we write this 32,768? Let's express that as a product of prime factors. Okay, so that can be written as 2 to the power of 15, and then because the bases are the same, we can then drop them and say that n is equal to 15. So if this series adds up to 65,534, then there are 15 terms. Now there's another very cool concept that happens with geometric series, and that is if your R value is anything between minus 1 and 1, then you can actually calculate the sum to infinity, because what happens is eventually the change becomes so small from term to term that it almost rounds itself off, if we can put it in very plain terms. Okay, and that's known as a convergent series. Okay, so they often like to ask us two things. They say, for which values will the series converge? And then we need to apply this knowledge here when the common ratio is between minus 1 and 1. Or they'll simply ask us, what is the sum to infinity? And then we can use this formula here. So it's just A, our first term, divided by 1 minus that common ratio. Let's try this in an example. Given the infinite geometric series, 4 plus, then our next term, 4 multiplied by 2k plus 1, plus our next term, 4 multiplied by 2k plus 1 squared. Okay, so we can almost guess that the next term is going to be 4 multiplied by this bracket to the power of 3. Okay, for which values of k will the series converge? So again, we apply just the formula part that we need. Okay, and we know that when the r value is bigger than -1 and smaller than 1, that's when a series converges. Okay, and if a series converges, that's when I'm allowed to calculate the sum to infinity. So I need to work out what r is. Okay, how do I do that? Well, r is simply second term divided by first term. Okay, or any two consecutive terms. So what we've got here is 4 times 2k plus 1, that's our second term, divided by our first term, which was 4. Now if I look at these r's, I can see the 4 is going to cancel there, and then I'll be left with just the 2k plus 1 is between -1 and 1. Okay, and then we solve this like we normally would. So we're going to take that plus 1 to either side. Remember, it changes sign. So it's plus in the middle. It's going to be -1 when we move it out. So we'll end up with -2. And we'll have here 2k. And then there we'll have 0. Okay, and then we can divide everything by 2. And so we end up with -1k and 0. So I can now substitute any value between -1 and 0 in the place of k, and I will have a convergent series. Now, for the sum to infinity, we've got this formula. So sum to infinity is equal to a over 1 minus r. Okay, so I know for which values of k r will converge, but somewhere in here I actually worked out r. But I think just to be clear, let's work it out up here. So r is equal to term 2 divided by term 1. So we simply ended up with r being equal to 2k plus 1. Now, if you look at this series, you probably could have seen that. You could have seen, okay, here we didn't have a bracket. We multiplied by a bracket. We multiplied by the bracket squared. And we carry on. So everything in the bracket is the r value of this question. And now we simply substitute in what we know. A was 4 over 1 minus this common ratio, 2k plus 1. And so that's going to be 4 over 1 minus 2k minus 1. And that becomes 4 over minus 2k. All right, this can even simplify more. Just take note there that plus 1 and minus 1, they kind of cancelled each other out. Okay, we can simplify this fraction like we would any other fraction. So 2 goes into 2 once and into 4 twice. And so we can end up here with a final answer of minus, because a plus divided by a minus is a minus, 2 over k. So that is the sum of the infinite series.